We'll kick off. And just to remind everybody that we are recording this, and hopefully you're happy with that. And I'd like to thank our the GNOSIS sponsors, Astra Agency and CGI and DSTL, who make these webinars possible. It is a small and intimate gathering. I have a feeling some people who've registered have decided to go off on holiday, hopefully somewhere where they're seeing this on Earth Day, as we are here in the UK. Without any further ado, though, I would like to introduce Max Alexander, who is really internationally famous science communicator and photographer. We've been very lucky to have Max share some of his work with us before in the past. And Max's latest exhibition, the whole project, which is about life in the sun's atmosphere, has been traveling, and we're quite lucky to be able to spend a few minutes with Max sharing those images and the story with us today. So Max, thank you very much for joining us. Hopefully we'll have some time for a bit of Q&A at the end, and people might filter in as we go, but I'm going to give the floor to you.
Okay. Well, thank you very much, Catherine. Lovely to see you all here today and amongst friends, really. So really, really great to be here. There's a bit of a tree surging out the back, but hopefully you can hear me okay, and we can show you these photographs in this exhibition. So I'm going to share my screen. Can you see that okay?
Yeah, although, yes, now we can see the slides.
Okay. Right. So Life in the Sun's Atmosphere, From Disruption to Resilience, is an exhibition primarily about space weather and the disruption that can come from space weather events on society and what's being done to try and address this issue. So the exhibition opened at Lloyd's of London. Catherine was here, very kindly came up from the South Coast, and there were about 200 people there. This is on the underwriters floor at Lloyd's of London, the global insurance market, of course, and a very good place to start because of this idea of risk. And it is of a concern to the insurance market, and it is a very underinsured part of the part of society, really. So to kick things off in the afternoon was a roundtable discussion. Might be some familiar faces there to you. There's Joanne Wheeler on the right. There are key people there from Lloyd's, from the insurance market. And on the left is John Younker from Viasat. So that, to me, was one of the best outcomes of the day, was this roundtable discussion. We can come back to that. But the impact on the insurance market and society in general was being discussed by insurance specialists in the space weather world, people in the space sector, aviation, the Met Office, across multiple sectors with their UK Space Agency, Royal Astronomical Society. There was a roundtable discussion. Gentleman with his hands in there is Craig Rogers. He flew over especially from New Zealand. So he's a professor at Otago University working with space weather. New Zealand, I've got a bias because I'm from New Zealand, but I did represent New Zealand quite heavily in the exhibition. There's about 10 of the 80 photographs in the catalogue at least from New Zealand. But it's a global issue, of course. We've got the Northern Lights, but of course we've got the Southern Lights. And so Craig talked about what they're doing in New Zealand, working with the power grid. I'll come back to that. That's Lucy Green there from University College London, MSSL, in the sky at night. Ian McCrea from STFC, working on the Swimmer Space Weather Resilience Program. Gemma Atrill at the Ministry of Defence, and also Peter Laidlaw at Atrium Insurance, given the insurance perspective. It was opened by Bruce Carnegie Brown, the chairperson of Lloyd's, and also there was a Cabinet Office Minister also opened the exhibition. At the same time, they concurrently released their impact scenario report, and working with the Cambridge Centre for Risk. I've maybe got that name slightly wrong, but they were there in force at the round table and throughout the day. And they've worked on a long-term study with Lloyd's of London, saying the potential economic impact would be 2.4 trillion to the global economy during a 5-year period. So the exhibition is called Life in the Sun's Atmosphere. I really wanted not just to tell the story about how space weather, geomagnetic storms in the sun can impact on society, but this more put in context, this more general idea that that sun sustains life, it gives us life, it sustains life, but it could also adversely affect our high-tech modern world. So that's the context. And just for a little, we've got some academics here, but just to help set the scene, if you talk about 1 astronomical unit is the distance from the sun to the Earth, the heliosphere, which is the extent of the sun's atmosphere, extends out to 121 astronomical units in one direction and maybe thousands in the other direction. So it's kind of like a teardrop shape. Now, I imagine you're all here very familiar what happens during a space weather event, but effectively what causes the northern and southern lights, you've got a flare from the sun, traditionally, that takes 8 minutes to reach the Earth, but the plasma can take anywhere from half a day to 4 days to arrive, depending on the velocity. I believe there's a flare on the way, a coronal mass ejection on the way at the moment, or something of that order. And it just one go, it can be very disrupting for our society. But we are right next door to the sun, and we very much live inside its atmosphere. All species, well, can be affected, in particular migratory birds who use the Earth's magnetic field to navigate by. And birds have been known to stop migrating during space weather events. So there's a record of that. There's also a correlation between whales being beached and space weather events. It's not a settled study, but there's quite a lot of evidence that there is some correlation between whales being beached and space weather events. So I photographed a total eclipse of the sun in April 2024, last year. And so I flew to Dallas, had a spy at the sky at night on the inside, texting me where they were, but I decided to drive 5 hours northeast to Arkansas, and I only set the camera up about half an hour before the eclipse, which is not very long. So I have to set up this sky tracker. I'm tracking with the rotation of the Earth, the long lens. It's a very difficult shot, and I only just got in the field of view and ready to go as it was getting dark. So I got very lucky. And this is you don't see the eclipse like this. But it's in reality, this is the sun's atmosphere extending out, the sun's corona extending out into space. So it's an incredible sight, and so I've taken multiple photographs and stacked those all together so you can see the features of the sun's corona streaming out from the disk of the sun, and that's of course the moon covering the sun there. So in May last year, May 10th, or was it 24th? In May last year, there was what they're calling the Gannon storm. It was named after a space scientist. She sadly lost her life a couple of weeks before the storm, but it caused major disruption. So about there were $500 million of losses in the United States from agriculture, so their tractors and other farm machinery during the planting season in particular. Lost the ability to, in some places, to plant their crops and other downstream services that you get from space as well. But that cluster in the middle, that sun cluster, it actually moved around a bit further south of there and towards the west for the event. But this is the cluster that produced those geomagnetic storms in May last year. So again, setting this in the context of life in the sun's atmosphere. So this is a comet. So the comet's tail, the gas tail, and the dust tail are both caused by the solar wind streaming off from the sun. And of course, the northern lights. This is in Iceland. This is actually geothermal energy center in Iceland. This is an academic at the at Goddard Flight Center working for NASA. So it's one of the few sciences that have a direct line to the White House. And Aniti here, Finnish, can't remember I'd have to look up his last name. But he's a solar terrestrial physicist, and you can see here magnetic loops on the surface of the sun. Photographed this at Imperial College in London. This is working on nuclear fusion, but this is this idea of plasma. So you've got the solar flare that can come from the sun, but you can also have you'll have the plasma that radiates out from the sun. So atoms that have had the electrons stripped off. So the most famous event, probably arguably in astronomy, depending, I suppose, if you talk about the supernova events, but one of the most famous recorded events was the 1859 Carrington event. So Richard Carrington was south of London. He looked through his telescope every day at the sun, and he just happened to be looking and at the precise moment when there was flare coming from the sun. So you see those red marks that sort of now faded into sort of a pinky magenta color. So these are his sketchings. He famously wrote in his diary, 1859, September the 1st, Thursday, fine with passing clouds. An extraordinary occurrence was witnessed, which is detailed below. Too busy cutting trees to watch for a repetition. Okay. And then this was recorded on the 2nd of September. So there were two events. It was like a cannibal event where potentially it was a cannibal event where one stream of material from the sun overtakes another one and has a compounding effect. So this was recorded at the Royal Observatory, Edinburgh. And telegraph operators of the day were being electrified. They tried to turn their power systems off, and they remained on with the current, these GICs, geomagnetically induced currents. And so you can imagine with today's technology what the potential outcome could be. There's also an event called the Miyake event, and these happen in the order of 500 to 2,500 years. They're recorded in tree rings, and these are super Carrington events, if you like. I don't know the exact term, but Miyake events in their own right. And so they could be an order of magnitude greater than the Carrington event. Carrington event may be a 1 in a 100-year event. Lucy Green thinks it might be more like a 1 in a 50-year event. It means it could happen tomorrow, it could happen in 200 years or whatever. But Lucy thinks it's perhaps more like a 1 in a 50-year event. And so we're kind of overdue for a Carrington level event. One narrowly missed the Earth in 2012. It was a glancing blow, and there was some disruption from that. I'm now going to go and talk about the impact on infrastructure. So there are three things that can happen, three major sectors. So terrestrial, in particular your power grid and all the knock-on effects from your power grid going down, aviation, and in space. And of course, we've got a lot of interest here from the space, the audience today. This is the power grid in Iceland. And I got very lucky. I was standing beside a road and a river to the right of me, so I could really only stand in one place, and waited there in the freezing cold in winter for a long time, several hours. And I got very lucky because the northern lights just came straight over where I was. I got a forecast for an event, a space weather event, for a geomagnetic storm to hit the Earth. And so I mobilized, flew up to Iceland with some aurora chasers, and found my spot to get that shot. This is in the Colorado, the Rockies. The auroral oval is actually comes further south around the Americas, so you can be further south and be affected by the northern lights and geomagnetic storms. The type of terrain, and that's one reason to use this picture, the type of terrain is important. This is mesomorphic rock in the Rockies. Sedimentary rock, which is what you'd see in the east coast of the Americas, is more prone because of the I don't fully understand it, but the way that the current is grounded sedimentary rock in, for example, in New York, and I'll come back to that. It was an event in 1921. With the increase in sustainable energies, they're actually more vulnerable to space weather events because of the nodal nature of where the electricity is taken to. So there's a star-like nodal nature, and so they can be more susceptible. They're further away from electricity centers, and so there needs to be consideration of that as this infrastructure is increasingly being built. Copper wire, of course, can be fried by these geomagnetic currents, and in particular, transformers. So this is in Quebec. In 1989, there was a major geomagnetic storm that hit the Earth, and it took the power grid out in Quebec for about 9 hours in the middle of winter. So there were knock-on effects. The metro was affected and was taken out in Montreal, and so it was a major disruption to that province. It's a picture in New Zealand during a power blackout. Perhaps a quirky photograph, but people may be on the move during a power blackout. There's going to be impacts from that, and it's important to plan ahead for it. So I went to about 8 different countries to tell the story. This is in New Zealand. This is in Lake Manapuri, which was built only for the main reason to power a aluminium smelter. It's about 100 kilometers away. And this is the smelter here. You can see the electricity pylons coming in from Lake Manapuri. So if this is what Lloyd's call a realistic disaster scenario, an RDS, realistic disaster scenario. So it's the knock-on effects from your power grid going down. So your aluminium smelter, basically your molten aluminium can solidify inside the casings, and that could cost tens of millions of dollars in loss, in business interruption. And if that whole plant was became inoperative permanently, that could affect New Zealand's economy by $1 billion a year. So I think that's pretty much what they output a year. So you can see the economic impact, the knock-on economic impact from a space weather event. Car manufacturing, if cars are being painted, they may have to throw away all the car bodies. Oil, gas, and water supplies, if the electricity system goes down, has a knock-on effect for all those facilities. This is in the Gulf of Mexico. I'm still calling it that. This is so where they point their drills is determined by the Earth's magnetic field. So they have to stop drilling during a geomagnetic storm because it throws out the Earth's magnetic field. And there's a business interruption here, so that's a cost to their operations. In 1921, I mentioned that before, the New York Railroad space solar storm. It took out the power grid and the rail network in New York, and there were some operators and some of the signal stations were electrified, and there were fires in those stations. So this is in New York City. With renewable energies, when we transition mid next decade, we are increasingly reliant on electricity supply. So that it's pretty obvious here that it would be more vulnerable to disruption from power supply failure. So as I said, there's two events. You can have this solar flare, which takes 8 minutes to reach the Earth, and you can have radio blackouts as a result of those. Can also affect telecommunications. This is in Berlin. This is in New Zealand. So both mobile phone networks and television signal can be affected. Now, amazingly, I saw this shot here and I just set the camera up and did that picture, and the Milky Way was right smack in the middle of those two pylons. So a bit of serendipity there, got very lucky, but of course kept shooting to show our cosmic perspective to this. So mobile phones are complicated, how you get your signal, but there's a space component to that. So, our mobile phone networks could be lost. Batteries only last for about 24 hours, and backup batteries at these for these transmitters. So then after 24 hours, your systems could fail completely if there was, say, a 3-day or a 1-week interruption to the services. And again here, payment using partly in part using GPS services. Distribution centers, this is in Scotland. So, all your uh, perishables will, of course, be lost during when you've got power failure, if the backup generators fail as well, or on a continuum of that order. Emergency services in Vancouver, the New York Stock Exchange, and it's important. So in this case, you've got time stamping, so billions of seconds, nanoseconds count during financial transactions. And a lot of those come from space, increasingly so, and I think that's their main system, but there are backup atomic clocks on Earth. So this is part of the resilience story, that there are systems in place for these events. Aviation, it's a really big concern. So, I don't think the chance of damage to human health is low on the ground. That's the received wisdom. But in the air, if you're at certain latitudes during a big event, I believe there can be an impact to your health, potentially from the radiation. GPS. So if your GPS goes down, so all planes use GPS, then that can affect your ability to navigate. So about a year ago, in the last 1 or 2 years, there was a radio blackout from a solar flare. So at certain latitudes, some planes were radio silent for 8 minutes, which is a very, very long time. And especially you don't know when you're going to come out of that period. So you can see the latitude here, 71 degrees north. So it gives it's those kind of latitudes that this would affect your flying. South Africa and Montreal Airport during that event in 1989 closed the airport for the day because of that geomagnetic storm. Keeping an eye on the time, which is getting on. So I'll race on a bit here. So this is now this is the third component, space. This is Starlink over London. Starlink launched during a space weather event a few years ago, and they lost, I believe, most of their satellites, about 40. And they're working with people at NOAA now and SWEPC, the Space Weather Prediction Center in the US and Colorado, to mitigate against those chances. So part of the story is also atmospheric drag. So as during a space weather event, the atmosphere can swell up and can catch your satellites and debris and deorbit them. So that is a potential loss of, as you can imagine, the assets in space. If there's a really major event like the Carrington event or worse, then we're extremely vulnerable in space, especially all your electronic componentry as it is on the Earth. This is a Brazilian satellite, but you can, get a sense here of all the electronics on board a satellite. Human space flight, astronauts can be affected by particles and radiation from the sun. This is at Goddard. This is at Houston, at the Johnson Space Center. So I'll just spend a moment or two speaking about this photograph here. So this is the Space Weather Prediction Center in Colorado at NOAA, the National Oceanic and Atmospheric Administration. And this is Bill Mercer. He's recently resigned in the last few months. But they're one of the few sciences that have a direct line to the White House. So they practice their operations once a month in the room next door, because a space weather event can be confused, as it was in the 60s once, from a nefarious attack. And also, do you shut your power grid down? Do you alert aviation? So that's a very big decision to take. So they've got all their thresholds, and increasingly they're localizing the area which can be affected. So it's a very, very important role that they have. This was shot during a space weather event, a solar flare, that really got their attention. They completely forgot about me and totally engaged and sent out alerts as a result of this. The Met Office down in Exeter have a MOSWOC, is the Space Weather Center down there. Final shot, final couple of pictures. This is part of the Vigil mission, which is going to be, well, probably cleared at the ESA Ministerial in November. It's looking very promising. They've already got a lot of pre-funding for the project. So Vigil will launch in the early 2030s, 2031, I believe. And this is a plasma detector. And they've also got a magnetometer from Imperial College. This is MSSL UCL down in Surrey, and also Imperial College are working on that. Solar Orbiter, of course, is already in operation and has a magnetometer and other instruments on board to monitor the sun. And then the final photograph was taken in October. There were two big events that came very far to the south, very southerly and northerly latitudes in the southern hemisphere. So this is the Northern Lights over London. So with that, I will make a stop and happily ask for any questions.
Thanks so much, Max. It's always, breathtaking photos, but also just, really lots of food for thought there. I mean, we see the sun as a clean power source, and have done for decades, but then understanding that renewables are particularly vulnerable, that's a new insight that, for me anyway. I see that Adrian. Adrian, I don't know whether you want to come on camera and put your question directly. Um, if not, I'll read it from the chat for you. Are you able to come on camera? Not seeing him. Well, I'll read that for Adrian. It's saying, as far as impacts to electrical generation systems, the transmission system is obviously affected. And the question is, are windmills and solar farms, themselves also subject to catastrophic failures?
Yeah. So, I mean, I'm not an expert, but I was told by Mike Lockwood, the president of the Royal Astronomical Society, that renewables were vulnerable. So we ran with that and did a bit of research on it. I don't know directly if the particular centers themselves are. I don't fully understand it, but there's some nodal or star-like nature of where the renewables are funneled to. So those points where the energy goes to is vulnerable to a localized geomagnetically induced current, GICs, geomagnetic storm. That's the
Really
piece.
feels like we need you to take your exhibition to the energy sector, to find a good place to have that talk with them. Mike, I don't know again if you want to come on camera and you've made a good point,
Yeah, I
thanking
can
you
do.
for an interesting talk, but also, yeah.
Yeah, that was really interesting talk, and it's kind of usually with academic talks it's full text, and this was exactly the opposite of that. So really enjoyable. I was wondering, so you really focus on all of the risks and problems here.
Mm.
The flip side of that is the technologies which are resilient. So thinking of things like optical fibers for communications, are there other ones that are worth kind of covering in this kind of presentation or advocating for in general as alternatives to these vulnerable solutions?
Yeah, I mean, I can't, I didn't set out to definitively cover all aspects. You can't do that. And there's going to be a lot of unintended, well, a lot of unknown consequences. So we don't know. There's an example I can give in a minute if we've got time. But so I'm just, I mean, I think I've gone through the main ones and give a representation of what those are. I don't know if I fully understood your question, but
I think because your talk focuses on, well, and your photos focus on the vulnerabilities, but you've mentioned, for instance, that the stock exchanges
yeah,
are ensuring that they have resilient
yeah,
time stamping
yeah,
sources. And,
yeah,
if the satellite position navigation timing time signal goes
yeah,
offline, then they do have a way, or they're developing ways of
yeah,
trying to, so to ensure that they have some resilience to that.
yeah,
And I think that's where Mike's question was headed, was just
yeah,
kind of, have you been able to look at any of the mitigations that people are using and
yeah,
been able to photograph any of that? I mean, this is a tiny little
yeah.
slice of your overall exhibition,
Yeah.
which, so yeah.
So in the exhibition catalogue, which I'd be very happy to put up in the chat if people want to download it and see the whole exhibition, there is a chapter final chapter's on resilience, but actually it was quite hard. I think it underlines, without being too pontific about it, that actually we are extremely vulnerable and underprepared. I mean, of course, electricity suppliers, energy companies are very tuned into this and they have experts, but you can always do more. Look, I'll give you an example. So during the pandemic, there were less than 10 transformers available around the world. I don't know what the number is now. It's vanishingly small in relation to what's the requirement. So in New Zealand, there were two transformers that went down on the east coast and the North Island during these biblical floods that they had, and people didn't have power for 7 to 10 days. So actually, the drug gangs were running the show there on the east coast of the North Island because they had the cash, and cash was king. So that would be one example of how that falls out. Now, the resilience piece, I mean, I think space is particularly vulnerable. The UK is leading on a swimmer program, which is a more than 3 year, £20 million program on resilience, including building apparatus to put onto planes which are already on British Airways and Virgin flights. There's also a unit they're encouraging satellite operators to put that on their satellites, prototype for that, and other various outcomes as well. So the UK, there's UK leadership in this domain. They totally get it. There's the Vigil mission, which is coming, so it's surveillance. But across the sectors, there's generally what I've come to know over the last 2 years is that actually we are extremely exposed. So it's like the pandemic. One day it's going to hit us and we're not prepared. And there is resilience, of course, across this, including especially the energy sector, and in aviation, but that's more of a mitigation, like an avoidance, perhaps. But we are very, very exposed.
I actually want to put, if he's willing, I see Harneet as an unofficial government representative, but given your engagement with INSPOC, if you're willing, Harneet, I'm just interested to see that the UK was one of the first countries in the world to put the impacts of space weather into their national risk register and to make that quite public. And then to update that later to understand, to really investigate the risk to critical national infrastructure on the ground and also in space. And I think there is a relationship between space weather events and your previous project about our fragile space, about debris, because my understanding is that space weather events change the position, change the drag, as you say, at the atmospheric drag, and so changes the position of all of the debris and also makes it difficult. I think we've lost Harneet, so I've put him on the spot and he's dropped off. Oh no, hello. Hi.
Hi.
2 seconds. And what I wanted to ask is the update to the risk register I see now has become more dynamic. In the 2025 edition, it's saying that instead of risks kind of being put on pause for 10 years and then refreshed, there's a more dynamic updating of the risk register now. There's a new approach from the Cabinet Office. And I'm just curious how frequently, are the UK government updating this space weather risk and the wider space risk? Because there's definitely this connection between debris and the potential of increased collision as a result of space weather impacts. We've also recently seen a study that showed in that Gannon storm that Max mentioned that actually thousands of satellites started maneuvering en masse due to autonomous station keeping capabilities, which didn't take account of the changed atmospheric drag because of the space weather event, or perhaps they did, but not necessarily by communicating their intent to maneuver en masse to all the other Constellation Network satellites that were also operating in low Earth orbit. And so that's another kind of brand new consideration, autonomous maneuvering of large numbers of satellites in low Earth orbit who are impacted by a space weather, sorry, I should say which are impacted by a space weather event. That's something that the last time the risk register was updated probably didn't get a whole lot of attention. So I really appreciate you coming on. But do you have any insight into the frequency of updating and how resilience and mitigations are being developed?
So I agree, yes, with your comment about space debris and satellite trajectories being impacted by space weather. Yeah, like you said, the number of spacecrafts which can automatically sort of adapt their trajectories automatically is growing. Obviously, as the ones that can automatically adapt their trajectories, they can do it, but then that means the ones that are non-maneuverable, sort of these ones that have automatically changed the altitude, could have a sort of further implication on the non-maneuverable ones. Yeah, and we did notice as well. So we track satellites, and we track sort of conjunction events and uncontrolled re-entry events. And when the Gannon storm occurred, there was a clear spike in the number of conjunctions that we were alerting on that month. And there was also a peak that.
Oh, we've lost your audio, I'm afraid. And you were saying something super interesting just then.
Sorry, did I just
You
jump for a
just
sec?
dropped out. Yeah, you said there was a peak also.
Yes, in October there was a large storm that occurred.
Yeah.
So there is a clear link there. What I think would be interesting is to find out exactly, sort of, to be able to quantify these numbers and to be able to say, if there is this level of storm, this is how much of an impact we can expect to see. So this is something that I'm trying to look into myself now. But there is an impact there. There is an impact that space weather does have on satellite trajectories and space debris.
Yeah.
And obviously it can cause objects to re-enter the atmosphere quicker than we expected as well. So as we're monitoring uncontrolled re-entry events, these objects can re-enter quicker. In terms
That's
of
interesting.
and in terms of updating the requirements, I'm not sure how frequently they would be updated, but as you're correctly saying, I'm not sure that we are taking into account the number of the satellites that can automatically maneuver now. So it's definitely something to think about, sort of, for the next iteration, definitely. And we will be bringing it up, and we have the data to sort of point towards as well now, which is great.
Thanks so much, Harneet. And I see that James has his hand up very politely, and we're running over, so I don't want to take up all of Max's afternoon. But James, did you want to come in?
Thanks, Catherine. And thanks, Max, for very interesting talk. I've had to close my blinds because the sun was disrupting my ability to see your wonderful photos of the sun, unfortunately. But I had a question. I think it's been touched on by Catherine slightly already, but you obviously had the Our Fragile Space exhibition 1 or 2 years ago now. I wanted to ask, have you noticed any I guess a comparison between the two in terms of how easy or difficult it's been to inspire, particularly the public, I think, is where I'm getting at, between those two topics, because of course they're quite overlapping as topics, but I guess in terms of photography as a medium, they're quite different in how you would portray the problem to a sort of public audience. So I wondered if you could comment on that.
Sure. Yeah, it's a great question. So, well, Our Fragile Space was launched in October 2022. So it's 2.5 years ago. It's still going strong. It's currently at the World Trade Center at Ground Zero in New York. It's 200,000 people a day go through that building. It's a major transport terminus. So it's already got tremendous exposure. It was at the United Nations for 6 weeks, European Parliament, Central Edinburgh, other venues still planned over the next 12 months. So it's a really hot topic. We all know that. Most of the people here are engaged with that. So that's been perhaps an easier sell, I would say. I've only, Lloyd's exhibition was only last month. It was in beginning of March. So it wasn't that long ago. I'm now looking for other venues, and so it's been discussed at various places. I've got a short list. So I think, though, I expect it to be more challenging to get that shown. Of course, it's solar maximum, so there's a lot of interest. The challenge is to, space weather events don't just happen during solar maximum. Historically, most of the big events, damaging ones, have happened just after solar maximum. But as Lucy Green was talking about, it's the intervening years, which is just as important to keep getting that message out. But I just think it's going to be harder to engage. Been very, very lucky to work with Lloyd's, just phenomenal support there, amazing. The team there, just amazing working with them professionally. It's a real highlight for me to work with these people. And they really go for it all out. So that's really fantastic buy-in. If people have got ideas, Catherine talked about the energy sector. I'm very interested to try and connect with them in whatever forum, be it a display or a virtual reality, and other venues we're working through. But in short, I think it's going to be a harder sell to policymakers and the public than the space sustainability, space debris piece.
Well, I think if we advocate for more outreach and more awareness raising, and within GNOSIS, we take great pains to try and bring the space weather story together with the story about debris and about safe, sustainable space traffic management, because we feel like people tend to kind of look at them through two separate lenses, and yet they're really so interdependent. So hopefully we can help you, put the word up to the powers that be to encourage that there's more of a joined up conversation about space weather and the space environment more broadly. So it's just we could go on talking all afternoon, but I'm going to call a halt there, because we try and make these short sessions where people can just learn something new and forge a couple new connections. So thank you so much, Max, for the talk and for your time and for sharing your fabulous photographs with us. We will take it offline to think about how we can get more exposure for that. And thanks everyone who was able to join. And anybody who we will be telling the people who registered how they can catch up with this later on our YouTube channel. So thanks very much, and have a very happy Earth Day, everyone.
Okay. Thanks, everybody. Great to see you today.